Okay, we've seen then that the matrix we get here is just the original matrix multiplied first on the left by this one, then on the left by this one, then on the left by this one, then on the left by this one. That's what this tells us. Okay. Now notice that this last matrix is what we call upper triangular. Now it's not absolutely necessary that we get ones on the diagonal here. Many times it's desirable, so I'm going to have them. But we could have stopped at this point. This matrix is also upper diagonal, and the whole process would have still given us what we're aiming at, which is a upper-lower diagonal decomposition, and you'll see what that means in a minute. Okay, so, and I said earlier that if I then multiply this matrix by its inverse, it's going to give me the identity, and the identity times this is just going to give me all of this. So I've written that out more explicitly. Okay, so in blue here, I've got, again, my original sequence of 5 matrices. Okay, then first on the left, I take this inverse matrix, and I wrote that in yellow, but this is the matrix that's inverse to this one. Okay, now if I multiply these out, this matrix times this matrix, and you can verify that it does give you the identity, but it must give you the identity if these two matrices are inverses. So these two matrices give you the identity times the next matrix, if you like, just gives us the next matrix, so the identity doesn't even have to be written down. Very much like writing a product of numbers, you don't have to write any ones in there because 1 times the next number is always just the next number. The identity times the next matrix is always just the next matrix. So that using the fact that this and this give us the identity, I just can kind of eliminate those, and I can write the product down without these two matrices. Now when I do that, here's what I get. You can verify it. Now this matrix is multiplied by this one, but because of the way I wrote these down, the order in which I wrote them down, this matrix is the inverse of this one, so this one times this one is going to give us the identity. Okay, and the identity times the next matrix is just the next matrix. Now I have just this and this and this and this, and of course my original matrix. Well, this is the inverse of this, so these two give us the identity, which doesn't have to be written in there. This times this is also going to give us the identity, so this whole product, if we continue, comes down to just our last matrix, which is our original matrix. Okay, so this whole product times the original matrix is just the original matrix, because this whole product is just a series of matrices matched up with their identities in the sense that we've seen. Okay, well, we know that the product of all these blue matrices is this. That's what we said over here. This times this, then on the left by this, then on the left by this, then on the left by this, we get this. So all these blue matrices go together to give us this product. Of course, that's been written up here also. So I've replaced all the blue matrices here in this product with this. Now, all the original yellow matrices are needed to counter these 4 blue matrices and give us just this matrix. If I multiply these matrices out, and it's really pretty easy to do because these are simple matrices, I'm not going to trace the steps, but you can verify it. If you multiply these 4 matrices out, this is what you get. Okay, so now we've established that the yellow matrix, which is the product of these inverse matrices, multiplied by the blue matrix, which is the product of these blue matrices here, has to be equal to the original matrix. Okay? Because this, which is this, times the product of these 5 matrices, which is this, is equal to this. Okay? Now, we observe that this matrix is lower triangular. It has only zeros above the diagonal. This matrix is upper triangular. It has only zeros below the diagonal. So now we have a lower triangular matrix multiplied by an upper triangular matrix. And L times a U equals our original matrix. And I didn't write that very neatly, but you should get the idea. Lower, upper decomposition of the original matrix.